On Christmas Eve in 2021, NASA's InSight lander received a gift of sorts, a new discovery. InSight recorded a significant Mars quake. That's what we call quakes on Mars. The InSight lander and MRO mission will explain how data and images from their space
relative locations of the InSight lander over on the left-hand side of the image, and this impact that caused a crater that we were able to pick up with our seismometer.
December of last year, a meteorite struck Mars and created the largest fresh impact crater we have observed in 16 years of MRO mission. Saw this image, we were extremely excited. This was nothing like we've seen before. The protuberance that this impactor created was so large, then we thought maybe we could see it in our other camera view. It's our, may I have my next image, please? It's our low resolution weather camera, but it takes daily global images of Mars. When we compare seismic epicenter with location that we pinpointed from the orbit and the time, we were able to match this large seismic event to our large impact crater. This is by far the largest jointly observed crater recorded seismically and observed from the image, from the orbit. A lot happens as the meteoroid strikes Mars. Rock gets fractured, details of the impact itself.
Thanks, Lilia. We want to study impacts with InSight because they can tell us not just about the craters themselves and the cratering process, but also about the interior and the atmosphere of Mars. From this high-rise image, it was immediately clear that this is the biggest new crater we'd ever seen. It's about 500 feet wide, about 2 city blocks across. And even though meteoroids are hitting the planet all the time, this crater is more than 10 times larger than the typical new craters we see forming on Mars. Most exciting of all, we saw clearly in the high-resolution images that a whole lot of water ice had been exposed by this impact. You can see in this flyover video of the 3D data boulder-sized chunks of ice in the crater's ejecta, as well as splotches of ice thrown across the landscape outside the crater. This was surprising because this is the warmest spot on Mars, the closest to the equator we've ever seen water ice.
Thank you so much, Ingrid.
So scientists are going to be able to use this to constrain the past climate conditions on Mars, when and how this ice was deposited, buried, and preserved up until now.
Asteroids are found throughout the solar system, and they play a really important role in planetary surface processes. So these observations are going to help contribute to that knowledge. I just want to speak for a moment about the importance of the discovery of ice, just below the surface. This is really an exciting result. We know, of course, that there's water ice near the poles on Mars, but in planning for future human exploration of Mars, we'd want to land the astronauts as near to the equator as possible, and having access to ice at these lower latitudes, that ice could be converted into water, oxygen, or hydrogen. That could be really useful.
As you probably know, as InSight's been sitting on the surface of Mars for the last 4 years, it's been collecting a lot of dust. What we believe is in the next short amount of time, perhaps somewhere between 4 and 8 weeks, as best we can predict, we expect the lander to not have enough power to operate any longer, and will lose contact with the spacecraft.
Time today. So to stay up to date with InSight, visit mars.nasa.gov.